every type of galaxy, spiral galaxies. We begin with the one you live in, a flat, spinning disk of a few 100 billion stars wound into bright arms that trail behind a glowing central bulge. It looks calm, a frozen pinwheel hanging in the dark. It is not calm. The whole structure is turning at hundreds of kilometers per second, and it has been turning for billions of years. Our sun is out near the edge in a quiet lane between two arms, taking about 230 million years to complete a single lap. You have never finished one orbit. No human ever will. The last time the sun was where it is now, dinosaurs did not yet exist. Here's the thing about the arms: they are not solid. They are not fixed lines of stars that spin around like the blades of a fan. If they were, they would have wound up tight and vanished long ago. Instead, the arms are waves, regions where matter piles up, slows down, and lights up. Stars drift in, glow brightly for a while, and drift back out the other side. The pattern stays. The stars passing through it do not. An arm is less like an object and more like a traffic jam that never clears. And that traffic jam is where stars are born. The pressure of the wave squeezes clouds of gas until they collapse into new suns. That is why the arms are blue and bright, studded with young hot stars, while the space between them is dark and old. A spiral galaxy is a machine for making stars, and the arms are the assembly line. And the arms come in flavors. Some spirals are grand designers with two clean, dramatic arms sweeping the whole way around, like the Whirlpool Galaxy M51, a textbook pinwheel 40 times fainter than the eye can see, but stunning in a telescope. Others are flocculent, their arms broken into dozens of short, patchy fragments, more like a fleece than a spiral. Same category, completely different faces. And the tightness of the winding varies too, from arms wrapped so loosely they barely curve, to arms coiled so hard they nearly close into rings. But here's the part that should reframe how you see the night sky. Almost every bright point you can see with your eyes is a single star inside this one galaxy. All of them. Your entire lifetime of stargazing has happened inside one spiral arm's worth of neighbors. The galaxy itself is so large that light moving at the fastest speed the universe allows needs 100,000 years just to cross it. And the Milky Way is not even especially big. Andromeda, the spiral next door, is wider still, and there are spirals out there that dwarf them both. Now take that spiral and reach into its center, because most of them are hiding something. Barred spirals, the upgrade you didn't notice you were living in. For a long time, we drew the Milky Way as a clean pinwheel, arms curling straight out of a round core. We were wrong about our own home. Our galaxy has a bar, a long, straight structure of stars cutting through the center, and the spiral arms attach to the ends of the bar rather than to the middle. Roughly 2 out of 3 spiral galaxies have one, including this one. Here's what the bar actually does: it is not decoration, it is a river. The bar funnels gas from the outer galaxy inward, feeding the central regions, feeding new bursts of star formation, and feeding the monster that sits at the very core. A bar is a galaxy plumbing its own fuel toward the middle, and bars come and go. Simulations suggest a galaxy can grow a bar, use it, dissolve it, and grow another over billions of years. The bar you see is a phase, not a permanent feature. Our Milky Way's bar may be a few billion years old. It may not last forever. Look at NGC 1300 if you ever get the chance. It is the poster child of barred spirals, a near perfect example with 2 arms springing cleanly from the ends of a bar, tens of thousands of light years long. It looks designed, engineered. It is not. It is just gravity and gas finding the same stable pattern over and over across the universe, which is why bars show up so often in galaxy after galaxy with no one drawing them. Let that sit for a second. The shape of your own galaxy, the structure holding your entire sky together, is a temporary arrangement. You just happen to be alive during this particular configuration. But not every galaxy bothers with arms at all. Some threw the whole disk away. Elliptical galaxies, the retirement homes of the universe, no arms, no disk, no pinwheel, just a smooth, featureless cloud of stars shaped like a stretched sphere or a fat egg, glowing a uniform reddish gold. If a spiral is a working factory, an elliptical is the factory after it closed. The gas is gone. Star formation has mostly stopped. What's left are old stars, red and cool, orbiting in every direction at once with no shared plan. Here's the reframe: ellipticals are not failed spirals. They are, in many cases, the winners. The largest galaxies in the entire universe are elliptical, and they got that large by eating. When two big galaxies collide and merge, the ordered disks are destroyed, the stars are scrambled into random orbits, and the result settles into a smooth elliptical blob. An elliptical is often the wreckage of a spiral that got too close to another spiral. And the biggest of them are almost incomprehensible. A giant elliptical at the center of a galaxy cluster can hold 100 trillion stars, not billion, trillion. Enough that if you gave every human who has ever lived their own galaxy of Milky Way size, you would still not run out of the stars inside one of these giants. There is one that holds the record. IC 1101, a monster elliptical sitting at the heart of a distant cluster, is one of the largest galaxies ever found, spanning millions of light years, easily 50 times the width of the Milky Way. Drop our galaxy into it, and we would be a minor smudge lost somewhere in its outer glow. Closer to home, the giant elliptical M87 anchors the nearby Virgo cluster, and at its center sits a black hole so large it became the first ever photographed. Ellipticals do not just retire, they rule. Here's the part that's quietly grim. These giants have essentially finished, they have burned through their gas, and they are coasting on the stars they already made. Slowly, over trillions of years, those stars will redden, dim, and die, with almost nothing new to replace them. An elliptical is a galaxy that has already lived its brightest day. But between the busy spiral and the retired elliptical, there is an awkward middle child: lenticular galaxies. The ghost of a spiral. Picture a galaxy with a disk, like a spiral, and a bright central bulge, like an elliptical, but no visible arms and no ongoing star formation. That's a lenticular, shaped like a lens. It has the skeleton of a spiral without the glow of one. The disk is there, the spinning is there, but the gas has been used up or stripped away, so no new stars light up the structure. Here's why they matter. Lenticulars look like the missing link between the two big families: a spiral that ran out of fuel, a galaxy caught in the act of settling down, keeping its disk, but losing its ability to shine with youth. They are especially common in crowded galaxy clusters, where a galaxy's gas can be ripped out simply by plowing through the thin, hot gas that fills the space between galaxies. The Sombrero Galaxy sits right on this borderline. Seen almost perfectly edge on, it shows a huge glowing bulge wrapped in a thin, dark lane of dust, so distinctive it looks like a hat floating in space. Astronomers have argued for years over exactly how to file it spiral or lenticular because it wears features of both. That argument is the whole point. The categories are not walls, they are a slow gradient, and a galaxy can drift along it, from a bright arm covered spiral to a smooth, quiet lens, changing so gradually that no single day marks the crossing. So, a lenticular may be your own galaxy's future. Use up the gas, stop making stars, keep spinning quietly as an aging disk of fading suns, not destroyed, just done. But some galaxies never had a neat shape to lose in the first place. Irregular galaxies, the ones that refuse to pose, no spiral, no ellipse, no clean symmetry. Just a chaotic, lumpy sprawl of stars and gas with no organized structure at all. Irregular galaxies look like someone started building a galaxy and walked away halfway through. They are usually small, usually rich in gas, and often furiously forming new stars in bright scattered knots. Here's the reframe: their messiness is not always original. Many irregulars were once ordinary galaxies, twisted out of shape by the gravity of a larger neighbor passing too close. The chaos is a scar. The Large and Small Magellanic Clouds, two irregular galaxies orbiting our own, are being slowly torn and stretched by the Milky Way's pull right now. And there is a rare, spectacular subtype worth naming: ring galaxies. When a small galaxy punches straight through the center of a larger disk like a bullet through a drum, the shock ripples the stars outward into a bright circular ring with a lonely core hanging in the middle. Hoag's object is the classic example: an almost perfect ring of blue stars around a golden center, with empty space between them. It looks impossible. It looks fake. It is simply what a head on collision can build, and irregulars matter far more than their size suggests. In the early universe, before galaxies had time to settle into elegant spirals, most galaxies were small, clumpy, and irregular. They are what the young universe actually looked like. When you look at an irregular galaxy today, you are looking at a survivor from an era when order had not yet been imposed on the cosmos. But there is a whole population of galaxies most people never think about, and it is by far the most common kind: dwarf galaxies, the ones that outnumber everything. For every giant spiral or elliptical, there are many, many dwarfs. Small galaxies from a few thousand to a few billion stars, faint and easy to miss. The Milky Way alone has dozens of them swarming around it like moons around a planet, most of them so dim they were only discovered recently, and more are still being found. Here's the thing that breaks the intuition: dwarf galaxies are the most abundant type of galaxy in the universe. When you picture galaxies, you picture the grand spirals in the photographs. But those are the rare celebrities. The universe is actually filled, overwhelmingly, with these small, faint smudges. The famous ones are the exception, and some dwarfs hide a strange secret. There is a type called the ultra faint dwarf, containing only a handful of visible stars, yet held together by an enormous amount of invisible mass. These are the most dark matter dominated objects known: a few hundred stars wrapped in a halo of something we cannot see that outweighs them 100 to 1. If you want to study the invisible skeleton of the universe, you study these nearly empty little galaxies. Take Sege 1. It is one of the faintest galaxies ever found, a scattering of just a few hundred stars, so dim it barely qualifies as a galaxy at all. Yet the way those few stars move betrays a gravitational grip hundreds of times stronger than their visible mass can explain. Something invisible is holding them. Sege 1 is almost entirely dark matter with a few stars sprinkled on top, like foam on a wave. If you wanted to weigh the invisible universe, you could hardly design a cleaner laboratory. Here's the humbling part: dwarf galaxies are also galaxy food. Big galaxies grow by swallowing small ones, again and again, over billions of years. The Milky Way is built partly from the shredded remains of dozens of dwarfs it has already eaten. Right now, streams of stars arc across our sky, the stretched out corpses of dwarf galaxies caught mid swallow. The Sagittarius dwarf is one of them, currently being pulled apart as it plunges through the Milky Way's disk, its stars smeared into a ribbon that wraps most of the way around our galaxy. It is not a clean death. It is a slow unraveling, one star at a time, over billions of years. You live inside a predator, but some galaxies don't just eat. Some of them roar. Active galaxies, the ones with a furnace at the heart. At the center of nearly every large galaxy sits a supermassive black hole, millions to billions of times the mass of the sun. Usually it is quiet, sleeping, invisible, but when gas falls toward it in large amounts, everything changes. The gas piles into a superheated disk, spiraling inward, and just before it vanishes, it blazes brighter than anything else in the galaxy. That galaxy is now active. Here's the scale that should stop you. The brightest active galaxies are called quasars. A single quasar, powered by one central black hole, can outshine its entire host galaxy of hundreds of billions of stars, combined hundreds of times over. The light comes from a region smaller than our solar system, 1 point brighter than a trillion suns, because matter is screaming as it falls, and they fire beams. Many active galaxies launch jets of particles from their cores at nearly the speed of light, blasting outward for thousands or even millions of light years, far beyond the edge of the galaxy itself. These jets can be longer than the galaxy that made them. A galaxy the size of a coin, throwing a spear the length of a room. The first one nearly broke astronomy. In the 1960s, a star-like point called 3C273 turned out to be billions of light years away, which meant that to look that bright from that far, it had to be releasing an absurd, impossible amount of energy. Quasar, they called it. Quasi-stellar. A thing that looked like a star and behaved like a catastrophe. And Mate 7's jet, the beam fired from that first photographed black hole, stretches some 5,000 light years out of the galaxy's core, a straight blue line of matter moving so fast it seems to break the rules of light itself. Here's the part that connects to you. Quasars were far more common in the early universe than they are now. The nearest bright ones are billions of light years away, which means we only see them as they were billions of years ago. The age of the great quasars is essentially over. The universe used to be a much more violent place, and we are living in the quiet aftermath, looking back at fires that have long since gone out. But active or quiet, spiral or elliptical, no galaxy exists alone. They gather. They fall together. And sometimes they hit interacting galaxies, the slow motion collisions. Galaxies are not scattered randomly through space. They cluster, pulled together by gravity, and within those groups, they orbit, drift, and eventually crash. When two galaxies collide, it is nothing like a car crash. The stars almost never actually hit each other. The distances between stars are so vast that the galaxies pass through one another like two swarms of bees crossing paths. But gravity does the damage. As they pass, each galaxy's gravity yanks on the other, pulling out long streamers of stars and gas called tidal tails, warping the neat spirals into bridges, rings, and grotesque distorted shapes. The gas clouds slam together and ignite furious bursts of new stars, a starburst, lighting the wreck up like a flare. Two ordinary galaxies become one of the strangest sights in the sky. We have caught dozens of these collisions frozen in mid crash. The antennae galaxies are two spirals tangled together, flinging out two enormous curved tails of stars that gave them their cores lit with newborn suns. The mice galaxies trail streamers so long and thin they look drawn with a ruler. Each of these was once an ordinary galaxy going about its business. Now they are locked together, and there is no undo. Once two galaxies begin to merge, over hundreds of millions of years, they finish. Here's the twist. This is not rare, and it is not far away. It is our future. The Andromeda Galaxy, the nearest large spiral, is falling toward the Milky Way at about 100 kilometers per second. In roughly 4 billion years, they will collide, tear each other apart, and eventually merge into a single new galaxy. Astronomers have already named it Milkomeda. Let that sink in. The Milky Way you belong to has an expiration date as a spiral. It will lose its arms, scramble its stars, and settle over billions of years into a smooth elliptical blob. The retirement home, the end state we met a few minutes ago. Your galaxy is on its way to becoming exactly the kind of galaxy it will one day eat, but there is one more type, and it is not a shape at all. It is what happens when you zoom out until galaxies stop being objects and become dots. Galaxy clusters and the cosmic web, the galaxy of galaxies. Pull back far enough and individual galaxies vanish. What appears instead is structure on a scale that makes a galaxy look like a single grain of sand. Galaxies gather into groups. Groups gather into clusters of thousands. Clusters gather into superclusters. And the superclusters string together into vast filaments of galaxies, wrapped around enormous empty voids, forming a pattern that looks unnervingly like a network of neurons. The cosmic web, the largest structure that exists, and we live inside a piece of it we have only recently mapped. Our galaxy sits in a small collection called the local group, which is falling toward a larger crowd called the Virgo cluster, which is itself just one district of an enormous supercluster we named Laniakea, spanning more than 500 million light years. All of it flows slowly toward a mysterious gravitational focus we cannot even see clearly. The whole neighborhood is being drawn somewhere, and we do not fully understand what is pulling. Here's what holds it together. Not the galaxies. The galaxies are the sparkles on the surface. The real skeleton is dark matter, invisible mass that outweighs everything you can see by more than 5 to 1, laced through the filaments, it's gravity pulling galaxies into the web like water beating along a spider's silk. Every type of galaxy we have met, every spiral and elliptical and dwarf, is just decoration hanging on strands of something we cannot detect directly. And here's the fact that should genuinely bother you. The whole web is being pulled apart. Dark energy is stretching the space between the filaments, driving the great structures away from each other, faster and faster. In the far future, every galaxy outside our own local group will slip beyond reach, its light stretched away into nothing. A civilization living then will look up and see only their own merged galaxy alone in an empty sky, with no way to ever know the web was there. There was a man who tried to line all of this up. A century ago, Edwin Hubble, the same astronomer who proved other galaxies even exist, sorted them into a diagram shaped like a tuning fork, ellipticals on the handle, from round to stretched, spirals and barred spirals splitting into the two prongs, from tight to loose, lenticulars at the fork in the middle. For decades, people read it as a life story, ellipticals aging into spirals, or spirals collapsing into ellipticals, a neat arrow of time. They had it backward and sideways and mixed up. The shapes are not steps on a single ladder. But the diagram survived because even a wrong map of the galaxies was better than no map at all, and it gave us the words we still use tonight. So let's put them all in a row. The classic spiral spinning and making stars, the barred spiral feeding its own core, the smooth elliptical, retired and vast, the lenticular, a spiral with the lights turned off, the chaotic irregular, a scar or a survivor, the countless dwarfs, food, and dark matter vaults, the blazing active galaxies with black holes for hearts, the colliding pairs tearing each other into new shapes, and the web that strings every one of them together across the dark. They are not really separate categories. They are stages and moods and accidents of history. A galaxy can be born irregular, settle into a spiral, grow a bar, light up as a quasar, collide with a neighbor, and end as an elliptical, all in one long life measured in billions of years. What you call a galaxy's type is just the frame you happen to catch it in, and every one of them is a place, hundreds of billions of stars, untold numbers of worlds, possibly somewhere in one of those faint smudges, something looking back at us, sorting our galaxy into a category of its own. We have named the spirals and the ellipticals, mapped the dwarfs and the web, and watched galaxies eat each other across billions of years, all from the surface of a single small planet orbiting one ordinary star in one arm of one barred spiral among 2 trillion galaxies. Not bad for stick figures on a rock